Models of the atom. In this lesson, we will learn about the history of how the atom model was developed and some famous scientists that contributed to that. First off, what is a model exactly? And that's just really any representation of an idea that is used to describe some sort of phenomenon or explain some sort of phenomenon that we cannot see directly and that we can't experience directly. So basically, to put it more simply, it's a representation of what we think is occurring. Models are often used by scientists to describe something. And all right, Dalton's atomic theory is what we're going to start off with here. Good old John Dalton. We're looking at around the early 1800s. Dalton actually had 5 postulates. He basically said that all matter is composed of extremely small particles, and we call those atoms. All atoms of a given element are identical, so everything has identical pieces. Atoms cannot be created. That means they cannot be divided into smaller particles, and they cannot be destroyed. The different atoms combine in simple whole number ratios to form compounds. That's why you see the little subscripts are whole numbers, like Cl2O4. They're whole number ratios. And then, in a chemical reaction, atoms are separated, combined, and rearranged. And so he essentially thought of the atom as a whole, like almost as a ball, three-dimensional ball. John Dalton did have mentors. He was a British Quaker, and he basically started out as a teacher. He didn't have a wife or any children. He was based out of Manchester, I believe. The one thing I do know about John is that he did write the first paper. It was the first paper on color blindness that was published. I want to say it was like around 1817, 1820. It was totally wrong. The biology was wrong. The light components were completely wrong. But he's known for that. But ironically, I believe what he's mostly known for is he was one of the very first meteorologists. So good old fun facts about John there. Then we move on to Thompson's model of the atom, J.J. Thomson. J.J. Thomson's model was called the plum pudding model. We don't really make plum pudding anymore. The closest thing I can think of is probably raisins in your oatmeal. So today we might call it the chocolate chip ice cream, where things are scattered throughout. The chips basically represent the negatively charged particles, which are spread evenly throughout a positively charged. So JJ is basically credited with discovering the electron. Um, you know, I've seen his burial site. He's buried right next to some people you might know, Charles Darwin and the famous Isaac Newton. Um, he's buried right next to them in the famous church, Westminster Abbey. But here we just have a diagram of JJ's model where we have a positively charged species with negatively charged components. And he basically gets credit for the electron. And on to Rutherford's atomic experiment, which led to his model. Ernest Rutherford, he basically designed this experiment with alpha particles, and they were going to pass through a sheet of gold. It was called the gold foil experiment. And he hypothesized after J.J. Thomson's model. Now, some don't know that Rutherford was actually one of J.J.'s students. JJ was a professor, and Rutherford studied underneath him. Rutherford also had this friend, you might know him as Hertz, Hertz, which is where we get Hertz, the unit, from. But Rutherford predicted that these particles were going to pass straight through that thin sheet of gold foil, and that's actually not what happened. So here's a drawing of his gold foil experiment, you can see that he's sending out a source of alpha particles and he's narrowing them down. He's got a deflector screen, and the gold foil is directly here in the center. And so basically, when he sent out these beams, some of them did pass through, but others started to bounce back. And he expected them to go straight, through the actual gold sheet. But when particles, which were smaller than an atom, started to bounce back, that triggered something in him, and so he's accredited with discovering the nucleus. So Rutherford's model is what we call the nuclear model, or the nuclear atom, where now we have gone from JJ's model to something with an actual center, a nucleus. And due to his wonderful discovery of the nucleus, he has a modern day, the highest, most scientific, prestigious award you could ever receive, not only a Nobel Prize winner, but also element number 104, Rutherfordium, has been named after him. Rutherford's one of the most unique scientists in that he's one of the first ones to win an award, if not the only one, from the continent of Oceania, also known as New Zealand. And if you want to know more about the new discovery of the new continent, New Zealand, you can take AP Environmental Science, and I will see you there, because there are no longer 7 continents. Or are there? Another one of JJ's students was Bohr, Mr. Niels Bohr. He studied with J.J. Thompson, and a classmate of his was Rutherford. Bohr hypothesized that the electrons rotate around the nucleus, kind of like how the planets rotate around the sun, and he's accredited with what's known as the planetary model. He, like his buddy Rutherford, also have the most prestigious award in science that you could possibly earn, and that is an element named after you. So he is element number 101, Bohrium, named after Mr. Niels Bohr. Niels Bohr's actually got a lot of interesting history. He not only won a Nobel Prize, but his grandfather, or his father, and his son all ended up winning Nobel Prizes. One of the funniest stories that I know of is Niels Bohr was actually friends with Einstein. And a lot of this is taking place in the 1920s, late 1930s, the beginning of World War II era. So basically, Niels Bohr and Einstein would have gentleman arguments about just different things in physics. And they became quite good friends. And I'm sure I can imagine these two having a conversation, sitting around a dining room table, and it being a very complicated version of if a tree fell in the forest, then what would happen? But anywho, Niels Bohr is also started one of the very first nuclear research centers, and I want to say it's in Switzerland, and that led up to the discovery of nuclear arms, which then we hit 1939, 1940, and now we're in World War II. So, but up until this point, all of these gentlemen fell short of the actual model, the modern day model, which we now teach to chemistry students, called the quantum mechanical model. And you will learn quantum mechanics in the electron unit that we do, where electrons have very specific seats. It's almost like they have their own boarding pass on the airplane. There's a specific place where they're supposed to sit, and that'll be in another unit. But until then, thanks for listening.